Welcome back, everyone. We are continuing with our Chapter 5 coverage here on cost, volume, profit analysis. In this video, we'll cover calculations of break-even points, some target profit analysis, and some margin of safety considerations. So learning objective 5 in Chapter 5 was to determine the break-even point. We have a couple different ways to do this. As I've said before, these aren't my favorite words to use in this class, but we do have what we call an equation method and a formula method. Let's keep in mind first that the break-even point is that point at which net income is exactly zero, right? Not sales at zero or anything like that. Net income exactly zero. So let's use our racing bike example from earlier study here to look at some break-even analysis. You may recall that Racing Bike Company was selling one type of bicycle. They were currently selling 500 of those things at $500 each, for total sales of $250,000. They had variable cost per bike of $300 and a CM per bike of $200. And at that sales level of 500 bikes, then net income was $20,000. So the formula method to figure out the break-even point is the shorter version relative to that equation method that we'll briefly touch on. It really centers on this idea that we talked about earlier, that each unit sold can provide a certain amount toward the bottom line. So toward covering fixed costs and then generating a profit. And that was our unit contribution margin measure. So for Racing Bike Company, every bike they sold contributed $200 toward that potential profit. So if we want to figure out the point at which net income is exactly zero, all we need to do is take the fixed expenses that we need to cover and divide by the amount that each bike contributes toward that goal. So that's why we have this little short formula method. Total fixed expenses that have to be covered to break even. In RBC's case, that's $80,000. Divided by the amount that every bike they sell contributes toward that, or $200, means they're breaking even at exactly 400 units or bikes sold. Now, the formula method can also be used to calculate dollar sales to break even rather than unit sales to break even. And all we have to do is make one little change. So we're still going to take the fixed expenses that have to be covered to break even and divide by contribution margin. But now, rather than dividing by unit contribution margin, we're going to divide by contribution margin ratio, right? That portion of every sales dollar that goes toward that bottom line profit. So in RBC's case, that's $80,000 in fixed expenses still, divided by their CM ratio of 40% gives us dollar sales of break even of $200,000. Now we are talking about the same point, right? This break even point is 400 bikes in RBC's case, or $200,000. It's the same thing, right? They're selling each bike for $500. So let's try another example here. Coffee Klatch is an espresso stand in a downtown office building. We were using this example in our last video. The average selling price of a cup of coffee is $1.49, and the average variable expense per cup is 36 cents. The average fixed expense per month is $1,300. An average of 2,100 cups are sold each month, so what's their break even in sales dollars? Pause this, work through that problem, and then come back for the solution here. So that would be $1,715. So again, we can find break even in sales dollars by taking our fixed expenses to cover divided by the CM ratio. Now in Coffee Klatch's case, that's fixed expenses of $1,300 divided by a CM ratio of 0.758 or 75.8%. Again, CM ratio is going to be our CM divided by sales. And CM, if we're looking at a per unit basis, just to untangle this all the way, is selling price of $1.49 minus variable expense per cup of 36 cents. So review that if you need to. But again, Coffee Klatch here, $1,300 in fixed expenses divided by a CM ratio of 0.758. And there's their break even in sales at $1,715. If we were trying to find break even in cups of coffee, we'd take the same $1,300 in fixed expenses and divide by the $1.13 in unit CM per cup. That's the $1.49 selling price minus the 36 cents in variable expenses. Okay, another example here is something to think about. Firms A and B each sell one product. Let's assume that's the case. Let's say firm A's product sells for $100 and has variable expenses per unit of $25. Firm B's product sells for $200 and has variable expenses of $150 per unit. If the two firms have identical fixed expenses, which firm needs to sell more units of its product to reach the break-even point? A, B, they'd be identical, or we can't tell from this information. Work through that, pause the video here, and then come back for the solution. So our answer there is firm B, and we can come up with this by thinking about the CM per unit of each of the firm's products. Firm B sells a product for $200 that has variable expenses of $150 per unit, so that unit's CM is $50. Firm A sells a product for $100 that has variable expenses of $25, so it has a CM per unit of $75. So unit for unit, Firm A's product contributes more toward its bottom line than Firm B. So Firm B is going to have to sell more units to reach their break-even point, assuming that fixed expenses are identical, as we said to assume here. That brings us to learning objective 6, which was determine the level of sales needed to achieve a desired target profit. And the nice thing about this target profit analysis is it's really just an extension of our break-even analysis. So here we're trying to estimate what sales volume, either in units or dollars, is needed to achieve a specific target profit. So firms quite naturally don't want to just break even, right? So in our break-even analysis, we're trying to find that point at which income is exactly zero. But instead, there's certainly probably a profit number that a lot of firms are trying to hit on a period-to-period basis. So we can extend that break-even analysis to incorporate some target profit. Now, your book talked about two methods, just like with break-even, equation or formula. We're going to stick pretty much to the shorter version here, this quote-unquote formula method. The reason I like to do that is because it's a very quick extension from our break-even analysis. If we're trying to find the unit sales needed to attain the target profit, all we have to do is take our break-even analysis, which said take your fixed expenses divided by CM per unit, and just tack on that target profit in the numerator. So we can sort of treat it almost as if it's like another fixed expense we have to cover. So we're saying in the top part here, the numerator, I need to cover all the fixed expenses, plus I need to cover this potential target profit, whether that's 10,000, 100,000, 10 million, whatever. Add those up, divide by the contribution margin per unit, which we know tells us the amount that every unit we sell contributes toward covering fixed expenses and generating a profit. And boom, there's my unit sales to reach target profit. So a nice little quick extension from our break-even analysis. We can also compute the target profit in terms of sales dollars using either of those methods as well. We'll stick mostly to that formula method, just as we did with our unit measure. So if we want to find the dollar sales to reach target profit, we can take the target profit, add to it fixed expenses, and divide not by unit CM, but by CM ratio now. So similar to our last point about the unit sales to reach target profit, this is a direct extension from our break-even analysis. The only thing we're changing is adding this target profit to the numerator as something else we have to cover with our contribution margin. Let's use an example of Coffee Klatch here again. Same basic information as before. So they're selling coffee for $1.49 a cup. Average variable expense per cup is 36 cents. Average fixed expense per month is $1,300. Use any method you want, but let's determine how many cups of coffee, how many units, would have to be sold to reach target profit of $2,500 per month. So pause the video here, work through this, and then come back for that solution. So that would be 3,363 cups. So unit sales to reach target profit, we want the target profit in question, $2,500 in this case, plus the fixed expenses, $1,300 in this case. There's everything we have to cover, divided by that contribution margin per unit, the amount that every cup of coffee I sell here contributes toward that bottom line. So that's the $1.49 selling price per cup minus the 36-cent per cup variable expense, or $1.13. Do that math out, and there we get our 3,363 cups. Now again, if we wanted to find the dollar sales to reach that same target profit, the only change we'd have to make is, rather than using the unit CM in the denominator here, we just use that CM ratio we'd calculated before. And out would pop dollar sales rather than unit sales. Now moving right along, learning objective 7 was to compute the margin of safety and explain its significance. Margin of safety, as the name sort of suggests or implies, is really the cushion we have in sales between our current sales level, or expected if we're trying to do some projections or what if scenario, and our break-even sales. We're trying to say, by how much can sales fall or drop before we start to cross that magic break-even point and operate at a loss rather than at a profit. So margin of safety in dollars can be calculated by just taking that total sales, current or expected, minus sales at the break-even point. So let's use RBC and look at their margin of safety. So I'm pulling forward what we had looked at earlier for them. Their break-even point was 400 bikes at sales of 200,000. They were currently selling 500 bikes or sales of 250,000. So they have a margin of safety of $50,000. 250,000 minus 200,000, and there's my margin of safety of 50,000. We're just saying, hey, sales of bikes here can fall by $50,000 before they start to become unprofitable on a month-to-month basis here. We can also express margin of safety as a percentage, and when we do so, that's percentage of sales. So in RBC's case, we'd take that margin of safety in dollars, the 50,000 we just calculated, and divide it by the current sales of 250,000. 50 divided by 250 is a 20% margin of safety percentage. So we're expressing the same thing, just in different units of measure. We're saying their sales can fall by by $50,000, which is 20%, before they start to operate in the unprofitable range. And then finally, we can also express this thing in terms of units. So this works best, of course, if we're only selling one kind of thing, simplifies things. But in RBC's case, we're saying, yeah, their margin of safety was $50,000, which is 20% of sales. If we take that margin of safety in total sales of 50,000 divided by the selling price of each bike of $500, that's 100 bikes. So their margin of safety is $50,000, or 20%, or 100 bikes. Just three different ways to express the same thing, essentially. Margin of safety telling us how much cushion do we have in sales before we go from profitable to potentially unprofitable. Okay, so that's it for this video on break-even, target profit, and margin of safety. Back up and review anything you want to see again. Let me know if you have any questions, and then move on to the next.